Hello, I'm going to walk through installing CEM, Cloudera Edge Management, and that will be also installing Minify Registry, Edge Flow Manager, and a Minify C++ agent. And we'll also install MOJO2 Python Runtime for executing the driverless AI motor scoring pipeline. So we'll start by launching an EC2 instance. Ubuntu T2 2x large. Storage, we'll update this to 128 gigs. Security groups, we'll add all traffic on all ports. IP 0.0.0.0. So all IPs are able to access this instance for testing purposes. Looks good, and we'll launch choosing an existing key pair, EC2 model deployment. Alright, now we'll click on it, add a name, CEM BAI MOJO. We'll copy the public DNS, we'll open the terminal, edit the bash profile, go to DAI MOJO CEM instance. This is the previous public DNS. I'm going to update it with our current one. In this file, I also have the PEM key. There's an environment variable that holds the path to that. Do a source. And now we're ready to use SSH to create a directory structure for where our input data will go and our motor scoring pipeline. Type yes. Now we're going to go to the DA model deployments folder, and that has the Mojo zip. It also has the MOJO2 Python runtime. So we're going to use this scp command to send over our Mojo zip. Note that it also has the home, downloads, and then mojo.zip. That is because I built this documentation in a way that, like, when you download the driverless AI motor scoring pipeline from your driverless AI experiment that you build, typically downloads go to your downloads folder. So that's why I chose that particular path. Now you can see on my computer, I have it in a different folder. Our Mojo zip file has been sent to our EC2 instance. We're going to send the MOJO2 Python runtime field file to our EC2 instance. So that's located in MOJO2 py runtime. Copy this scp command, we'll slightly modify it. Now that our MOJO2 Python runtime is sent over to EC2, we're going to send over our driverless AI license file, and that's also in a different location on my local machine. Desktop, model deployment, common, license. Alright, and we're going to copy the and paste scp command, slightly modify it. We can directly specify the license sig and send it to home Ubuntu. Alright, now we're going to run SSH to run these commands remotely on the EC2. So we're going to do echo export driverless AI license file, the path to the license file, followed by a pipe sudo t. We're going to append that to the root profile. Minify C++ will be it will be started by the root user. So we just want to make sure that the root user also has access to the driverless AI license file. When Minify runs, it's running by the root user, so the root user needs access to this. It's a verification step. We will SSH into the EC2. Sudo su, and we'll do a cat followed by profile. If we can see that it did work. Alright, clear the screen. Okay, next we're going to be installing CEM and the Driverless CI MOJO2 Python runtime in the EC2. So what we'll do, we'll set our Cloudera license credentials, so Cloudera license username, a UUID, and Cloudera license password. You can get this from Cloudera. If you're buying Cloudera products, they will provide you with a set of license credentials, and if you're a partner, you can also get their license credentials. So I'll set these as environment variables. I set the Cloudera license credentials as shell variables. Okay, so now what we're going to do is we're going to use SSH to get cloned DAI deployment examples repository onto our onto our EC2 instance. So now that we cloned our DAI deployment examples repository onto our EC2 instance, now what we're going to do is we're going to execute the setup.sh script using SSH. This script is on our EC2 instance in the DAI deployment examples folder, which is in the MOJO.py minify cpp folder. We'll be executing this script as a sudo user and passing in the Cloudera license credentials to download CEM, install Edgeflow Manager, NiFi Registry, minify C++ agent, one agent, and also the MOJO2 Python runtime. With the installation finished, now let's check if we can access NiFi Registry UI, the EFM UI, and if not, then we'll take the appropriate troubleshooting measures to make sure that we can. So we'll copy and paste this link into our browser. We will copy the public DNS. Okay, so we scroll down in the documentation here and I have a troubleshooting section. Troubleshooting CEM starting up the components. So we are going to SSH into our EC2 instance. Alright, and then we're going to go into being root user. Right, and then we're going to look at the status of our NiFi registry. Currently it's not running, so we're going to start it. Now if we check if it's running, it's currently running. We'll refresh this page. Currently you can see this is the dashboard of NiFi registry. What will typically show up here is every time you create an EFM data flow for a Minify C++ agent and publish that data flow to an agent, those data flows will be saved to NiFi registry. And so let's check if there's a bucket. There aren't any buckets yet. And to give you some background context, we're going to go to EFM. And then the conf directory, or EFM properties, tell EFM which particular bucket to look at. So here we can see there's a bucket name. We're telling EFM, look at NiFi registry's bucket name DAI MOJO, and for when you publish your data flows to Minify C++ agents, or Minified agents, save those data flows to this particular bucket. And there isn't a bucket created yet, so we have to create one. Okay, now that that bucket is created, when we publish our data flows, EFM will save them to this DAI MOJO bucket, and they'll show up on this main dashboard here. Quit that. Now what we'll go look at is EFM UI. And I also need to get the public DNS. We can see EFM has started. Let's check if the Minify agent is running. One way we can do that is we go down here to the troubleshooting section as well. There's a minify.sh status. And it says that it's currently not running, so we're just gonna start our Minify agent. And we can check. We can see it's currently running now. What Minify does when it's running is it sends heartbeats over to EFM, and our Minify agent is associated with this agent class. So where we can see that and how Minify communicates with EFM is in the Minify conf directory. So in CEM folder we have NiFi, Minify, CPP, and there's a conf directory and then Minify properties. So in Minify properties we have NiFi C2 enable, so enabling C2 server, EFM is C2 server. and then we have the NiFi EC2 agent protocol class. We have this specified as REST sender, so this is how MiniFi is communicating with EFM. And then the NiFi EC2 flow base URL, REST URL, REST URL acknowledge, and for these we're just passing in EFM's public DNS. And this is how MiniFi is able to communicate with EFM. Also, something to note too, because we'll be using custom MiniFi processors that are Python processors. We specify where our Python processors are located with the NiFi Python processor directory, and we can see our H2O relevant processors are in this particular directory path. So now we can go to the design, and we're looking at OpenFlow, and we can click on this class that we want to design our flow for a particular MiniFi agent that's associated with that. Oh, right, and also one more thing. We can see here that there's a NiFi EC2 agent class. So this is saying that our MiniFi C++ agent is a part of this class. So when we design a flow for this class, we're going to be designing it for this MiniFi agent that's a part of this class. And then its identifier is the MiniFi CPP DAI MOJO PY001. Then we can check our list of processors here. We have the execute DAI MOJO scoring pipeline, the convert DS to CSV. There is a custom Python processor we're missing, which is the execute H2O MOJO scoring. So let's troubleshoot how we can add that custom Python processor to EFM. So what we need to do is we need to update MiniFi C++'s agent. So the MiniFi C++ agent's manifest JSON file. And so in this documentation here, I have a troubleshooting section on troubleshoot custom Python processors not showing up in EFM. And so what we can do is we're already in the config folder for the MiniFi C++. We'll just use this curl command. We're going to get MiniFi C++ agent manifest identifier that's associated with the class. And then we're going to update this with our EFM public DNS. So just copy that. Okay, now we can see that there's the identifier there. And what this command is doing is we're going to download the current MiniFi C++ agent manifest and save it to a file called manifest.json.txt. And this is where we're making sure to also insert the agent manifest identifier, which we got from the previous result. So this identifier that's currently in the command is the previous one from the last time that I had to update MiniFi C++ agent manifest. So we have the one we need, which is right here. So we're just going to copy this one and replace the current one that we see. And we're also going to update the public DNS. Okay, and we should see that we now have the manifest JSON text. If we were to search this file, what we would find, so we could do VI, we could search for execute H2O, and we won't be able to find that particular processor. DAI MOJO scoring pipeline is there, and so is the convert DS to CSV. So we're going to update this. So the DAI deployment examples MOJO PY MiniFi CPP project that we cloned from GitHub has the updated agent manifest JSON file. So we're just going to overwrite the one that we just downloaded to MiniFi's conf directory. And then we're going to run this curl command to upload the updated minify C++ agent manifest JSON file back to EFM. And we're going to keep that public DNS. Okay, we can see that HTTP 1.1 201 created, which means that we've successfully uploaded the updated minify C++ agent manifest JSON file to EFM. Okay, and now the last part that we need to do is we need to associate this new minify C++ agent manifest identifier with our agent class. Our agent class in this case is the minify CPP DAI Mojo PY1. And the identifier that we're going to identify that class with is this new one that we see here. So we're going to get this example, curl, copy it over. We're going to copy this new agent manifest identifier. We're going to replace the current one, which is right here. And then we're going to also update this too with the public DNS. Of our EFM EC2 instance. And so it looks like we successfully associated our new minify C++ agent manifest identifier with our class that we want, and we can see that by HTTP 1.1 200 OK, which means success. Okay, now what we can do is we can check this. So all we have to do is close that, reopen it, and we can see that in fact we now have access to the execute H2O Mojo scoring processor too. So we have access to the custom Python processors that we need, which are just convert DS to CSV and execute DI Mojo scoring pipeline. I wanted to bring in the execute H2O Mojo scoring just in case for like a future project we may want to use that one. But at this point we have what we need, and in the next demo video I'll show you how to build a minify data flow in EFM and then publish it to the minify C++ instance on our EC2 instance and look at the predictions.